This is Moumita Sharkar. We are going to go through the first task assigned as a part of the GRIP May 2021 internship. I am using Python as my preferred choice of language. The problem at hand is to predict the percentage scored by a student based on the number of hours studied. We have been provided with the study hours dataset. We are going to fit a linear regression model for two variables, namely hours studied and scores obtained. Once we fit the model, we can use it to predict the score a student is likely to achieve if the student studies for 9.25 hours per day. Since the context has been established, we will gradually go through the code. First, we import all the packages that are going to be necessary for proper execution of the code. As you can see, I have imported the pandas, numpy and matplotlib packages, which is pretty common. Next, what I am doing is importing the input output package, and why I am doing so is in the next set of codes. What I am doing here is using this snippet of code to upload the data set from my own device, which I thought would be a nice change of pace and also something others can use if necessary. Next, we assign the data set to the variable df, which is perceived as a data frame. I have also printed the shape of the data set, which is nothing but the rows and columns of the data frame. Then I use the .info function, which is very useful when trying to understand if there are missing data points. For this data set, we don't have any. Then we also use the .describe function, which exhibits the basic descriptive stats of the numerical factors of the data set. Then I visualize the data frame, which I would highly recommend if possible, as that gives us a very distinct idea regarding the distribution of the values. When plotted, we look for the distinct pattern or clusters the data follows. In this case, the data is linear, which I can conclude from the increasing progression the data follows. Then what I am doing here is separating the factors into arrays and printing the number of rows and columns, which can be done by the dot shape function. Then what I am doing is I am splitting the data set, the entire data frame or the columns I am splitting into two different arrays. One is for training the data set and one is for testing the data set. And this is done randomly, and this one-liner exactly does that function. Then what I am doing here is creating a regression. I am importing the linear regression package from sklearn, the linear regression module, and then I am using regressor equals to linear regression function, and then fitting the data using the train data values that was present in the subplot for training x and y values. I am using that and then printing training complete, so that I can understand that the process of fitting the data set has been successfully completed. Then I am creating the regression model, which is this is the dependent variable, and then the regressor coefficient, then the x values, and then the regression intercept. So what here happens is we can now draw the fitted line based on the values. Since we have plotted the data set, I am predicting the y values based on the test values. The data frame, from the data frame we are then printing the actual values and the predicted values, the ones we got from the test values using the fitted linear regression model. We then find the MAE or the mean absolute error to be 4.183, which implies that the predicted value is 4.183 away from the true value. Then we are using the R squared value or the measure of goodness of fit, which is 0.9454. Hence, the linear regression model explains 94.54% of the variability in the data. So this concludes my task, and thank you for giving me this opportunity to do this project.